Hello, in this video, we are going to look at dissecting what a stoichiometry word problem looks like and help you work your way through the steps of setting up a stoichiometry problem to the point where we are ready to pick a method of calculation. Your stoichiometry problems are going to describe some sort of chemical reaction. So in this example, we have nitrogen and hydrogen gases combine to form ammonia in the Haber process. If 2.00 moles of nitrogen reacts with excess hydrogen, how many grams of ammonia are produced once the reaction is complete? So step one of any stoichiometry problem is to write and balance a chemical equation. In this problem, we're not given a chemical equation, we're given this reaction statement. So we have to turn it from words into symbols for our equation. So we know that nitrogen, since it's diatomic, needs to have a symbol and a subscript 2. Hydrogen is also diatomic. To combine or to form is our action word. And ammonia has the formula NH3. We use this one a lot, so you'll probably memorize it as a common name before you even know it. So I wrote everything nice and far apart. I don't have to include the states because they're not super important at this stage. So we just have a nice, simple, clean skeleton equation. So step one is to write the equation, but also to balance the equation. If we look at these values, they are not balanced. So we need to go in. I need 2 nitrogens. Remember, my coefficient in front is the same as my mole ratio number. That means that in my reaction, I'm going to have 2 moles of ammonia reacting with 1 mole of nitrogen. But this 2 doesn't just apply to the nitrogen atoms, it also applies to the hydrogen atoms. So I have to take this 2 times the subscript 3 to get a total of 6, which means on my reactant side, I need a coefficient 3 to get my fully balanced equation. Step number 2, now that my equation is balanced, I'm going to add in or otherwise show the information that has been given to me in the problem. So if we look at the problem, it says that I have 2 moles of nitrogen, and it reacts with excess hydrogen. So anything that goes with an element, you want to put near that element. So I'm going to write that hydrogen is my excess reactant. More on that in a second. And that nitrogen has 2.00 moles. Whenever we are going to be working with stoichiometry problems, we want to make sure that we're working in moles and not grams because we're comparing mole ratios of numbers. Recall that 1 mole of any 2 substances will have the same number of particles, but 1 gram of any 2 substances will have a different mass, different number of particles. So we want to make sure that we're in moles. Since we're already in moles, we don't have to do any converting here. We can go ahead and move on to step 3 of our stoichiometry calculation. Step 3 says to determine the limiting reactant. Sometimes we're going to determine mathematically which of these is the limiting reactant, but in this case, the problem tells me that I have excess hydrogen. I can only have 2 types of reactants. I can have excess reactants, and then I can have limiting reactants. Since I only have 2 reactants, and I know that my chemical reaction is going to take place until I run out of at least one of my chemical substances, that means if this hydrogen is in excess, the other element has to be my limiting reactant. We want to determine which of my reactants is the limiting factor because that is the ratio that we are going to compare any other values to, like we will in the following example. We can also use this little step to ask ourselves, what am I trying to find? In step 4, we're going to use mole ratios to solve for our unknown. So we have to figure out what our unknown is. So if we read the problem is asking us how many grams of ammonia are produced once the reaction is complete. So as soon as I run out of that limiting reactant, how many grams of product was I able to make? So that makes my unknown how many grams of ammonia that I have. In the next 3 videos, I will show you 3 different methods to performing the calculation that would actually give you this answer. Stay tuned.